So we're going to look at the concept of replacement now. And we've touched on this a little bit before. But we know when we're doing things, when we're taking something out of a bag or drawing a card or doing something where we're picking up something, replacement matters, yes.
What's that little?
It's the microphone. Good
Oh,
stuff. There we go. So,
Yeah.
what's something we could use to help us figure out this? What's a tool we could use
Which one?
to figure out probability when we're talking about multiple events?
Percentage.
We can use percentage as our way of representing that, but what's something that we've seen before that helps us sort of figure out the odds of these things occurring? Starts with T, I'm looking for.
2 tree diagram.
Tree diagram, very good. So we can use a tree diagram to help us figure this out. So what I want you to do now is in our books we're going to draw our own tree diagram. How many branches should it have, or how many little midpoints? 2, because we've got 2 events, correct? Event 1, and then event 2 off that. Nick, what do we define as a success in this scenario? Getting a red card, correct? So drawing a red card is a success. We need to get 2 red cards in a row. So my tree diagram should have R and yeah, you can have not R, so R dash, or you can have B, so B or R. Cool? Either is fine. That will be the same in both tree diagrams, won't it? Because in both scenarios, I've got red and black cards. In both scenarios, I need to draw 2 reds in a row, correct? So what changes about these diagrams? With or without replacement? What's going to change?
Without replacement, the previous selection.
Yeah, so with replacement means when I pull out, say I pull out my first red card, I then put it back in the deck, shuffle it, and pull out another card, correct? Without replacement, I pull out the card, look at it, throw it away, grab another card. And that's going to impact the probability, isn't it?
Yeah.
Because if I get the jack of hearts, say on the first draw, can I get the jack of hearts if I don't replace? Is it possible?
No.
So I've taken 1 red card out, which means I'm no longer 26 out of 52. I'm now 25 out of 51. Cool? Well, let's go through first of all. We'll go through without replacement. Sorry, with replacement. So we'll do with replacement first. So with replacement, Nick, what's the odds of getting a red card on my first pickup?
25%.
On this one?
No, half.
Half. Because there's how many cards in a deck? 52, and how many in the red?
Half of that.
Which is? 26, very good. Why am I representing it as 26 over 52? You were right to say half. Why am I choosing to do it this way?
Because the second one's in 25.
Very good. I'm trying to show that we're going to get a different result in a second. Very good. So, Mark, what's the odds of getting a black card on my first go?
Yeah, the same.
Exactly the same, I'd say. 26 out of 52, very good. Matt, with replacement, so I'm putting the card back in, what's the odds of pulling a red card out of my second draw?
26 out of 50.
It's exactly the same as 26 out of 52, isn't it? And a black card?
26 out of 50.
And it's the same regardless, correct? How would I calculate the probability of that line? What's the operation we do? So I've drawn my tree diagram. That's helped me. How do I use it?
Convert.
Well, let's look at what are the successful pathways. So which pathway is successful here? Jade, is the bottom one successful?
No.
Is the second bottom one successful? Is the third bottom one?
No.
Is the top one?
Yes.
So that's the only pathway we want to look at, correct? We just want to look at this pathway here. Now, if I want to find the probability of a pathway, Jack, what should I do? I've got some operation, I've got 26 over 52, some operation 26 over 52.
So, when you just go 100 divided by 4, Fraction, no, you're good.
Not this number.
No.
That's because this is an equal probability one, so we could make it a bit easier, but the next one's not going to be. So I'm just trying to give us one process that works for everything, rather than remembering different processes for different ones. So Jack, you were saying, what's the operation that goes on here? Time, very good. Now, would I expect you to do that in your head? 26 times 26 divided by 52 times 52? What could we use? I'm so good I already know the answer, but put it in your calculator, see what it is. On the lower side. Yeah, I've got to go. Let's get it down. That's good. My hand, here we go. All right, so Jack's nailed it. Jack, who do you reckon should help me on the next one? You reckon Jack Appo? Okay, I agree. Jack Appo should. I can redraw this, and I hope that you will redraw when we finish doing this. But does the first card change with or without replacement, or is it exactly the same Jack Appo? The first card I draw, does anything change?
No,
Nothing changes on the first one, correct? Where does it change?
second one.
Second one. So what I'm going to do now, same pathway, correct? Same pathway successful, but I'm going to fill out the whole table. I'm just going to rub these numbers out here. Now you guys are going to redraw it in your book, obviously, but I'm just doing this so we don't have to get confused. What changes?
Cheers.
The chance changes. How does it change? Well, if I've drawn a red card here, how many successful cards are left?
25.
25. So all I'm doing is taking one of 26, correct?
No. You take one of 52.
Oh, very good. I've got to take one of 52 as well. So I've got 25 over 51, correct?
Mm-hmm.
Awesome. Vaughan, what do you reckon the odds of getting a black card on my second draw is? 26 over? 51, very good. It's a bit of a trap. James, I've now drawn a black card. I'm going to do the whole table. We don't need that, but I'm still going to do the whole table.
Yeah.
Okay? Just good practice. What's the odds of getting a red card after I draw a black card?
26 over 51.
26 over 51, very good. And what's the odds of getting a black card after drawing a black card, Max?
20, 25 over 51.
Very good. Now again, I want to calculate this probability. How could I go about doing it?
Calculate.
Because that's not going to be exactly 1 out of 4, is it? It's going to be something a bit different. So I need to do the same process that I had before, but with my new numbers. First number, is it any different? Is my first number any different, or is it exactly the same? The same. So it's still 26 over 52 times what? Mark, what am I multiplying for?
25 over 51.
Very good. And now I get my calculator out and I shove that in. Now I was so good last time I could get one over 4. I'm not going to do it this time. Don't overexert myself. It's because I can't do it. Exactly right. I can't do this one. Why can't I do this one? In my head.
Because it's dependent.
Well, I can't simplify the second fraction, can I? This first one's 1 over 2, but the second one I can't simplify. I actually do know the answer. It's 25 over 102. How do I do that?
You just plus the door.
Well, 26 over 52, that can become 1 and 2, correct? Times 25 over 51. It's top by the top, bottom by the bottom. What's 1 times 25?
Oh.
And what's 51 times 2? 102. So I could do it, but that's a nice and simple example. Would I expect you to do that on your own? No way. I'd expect that we'd be able to, we've got our calculator for those sorts of ones. Cool. Sweet. So what I want you to do now is I've given you this